Guys, so today I'm going to talk about UFO and aliens here. So let's start off with this one. What is UFO? So UFO, it's a term, stands for unidentified flying objects. The term was created by the United States Air Force, USAF, in 1953. The initial meaning was any airborne object whereby its performance, aerodynamic characteristics, or unusual features does not conform to any currently known aircraft or missile type, or which cannot be identified as a familiar object. And now moving on to the second one over here, which is the history of UFO. So the very first well-known UFO sighting occurred in 1947 when a businessman, Kenneth Arnold, claimed to see a group of 9 high-speed objects near Mount Rainier in Washington while he was flying his small plane. Arnold estimated that the speed of the crescent-shaped objects as several thousand miles per hour and said that they moved like saucers skipping on water. In the newspaper reported that followed, it was mistakenly stated that the objects were saucer-shaped. So there's this term called flying saucer. And moving on to the next one, which is conspiracy theory of UFO over here. So this is about the conspiracy theory of UFO, which is in Area 51. So in the so this picture over here, it's Area 51. And in the 1950s and the 60s, multiple UFO sightings were reported around this area, Area 51 in Nevada, a site used variously by the CIA, the US Air Force, and Lockheed Martin to test flights of experimental aircrafts, or they call it the black aircraft. So declassified documents shows that Area 51 was a home to a Cold War program called Oxcart, dedicated to creating spy plane that would be undetectable in the sky and could be used to gather information behind the Iron Curtain, which is basically Russia. So the resulting SR-71, which is a plane, this one over here, this is SR-71 Blackbird, and F-117 Nighthawk, this one, and also the Archangel 12, which is this one. And 3 of these planes, they are capable of traveling at high speed of more than 2,000 miles per hour. So these mysterious planes help fuel the rumors that Area 51 was used to conduct experiments on extraterrestrial beings and their spacecraft. And now moving on to this one, which is the conspiracy theory about the Roswell incident. So the same year that Arnold saw the flying objects, there's this rancher by the name of Mac came across a mysterious 200-yard long wreckage near an army brazil near an army airfield in Roswell, New Mexico. So the local papers reported it was the remains of a flying saucer. The U.S. military issued a statement saying that it was just a weather balloon. Told the newspaper, photographs suggested otherwise. The flames of conspiracy were further fanned in the 1950s when dummies with latex skin and aluminum bones that looked eerily like aliens fell from the sky across New Mexico and were quickly picked up by the military vehicles. So, to those who believed in the earlier Roswell sightings, this seemed like a government cover-up. For the Air Force, these dummies drops were a way to test new ways for pilots to survive falls. 50 years later, the military issued a subsequent statement admitting that the Roswell wreckage was part of the Project Mogul. So this Project Mogul is a top secret atomic espionage project, but who knows, right? And moving on to the last one, which is how are Area 51 and other army bases around the US related to UFO researchers. So it is believed that these army bases are not just built on the surface of the earth, but also levels and levels deep underground. The locations of experiments are believed to change from time to time between the army bases to prevent leakage of classified information and also to avoid unwanted attention from the public. You see, why would they want to build such secret tunnels underground if it's not something that's so secret enough to hide from the public? And this is the suspicion place. And also it is believed that the army bases are connected together by special tunnel network, as I say. Besides that, it is also believed that the researchers involved in the study did reverse engineering on UFOs and other technologies from the extraterrestrial beings, and that is why those mysterious planes actually exist, as in referring to these planes. All these three planes, yeah. And that's from me. Thank you very much.
Good morning, everyone. So today our group is going to talk about space. Now, space is a vast topic which can't be done in just one video. So what our group decided is to talk about some of the interesting items on the space. So what captivated me is this red planet known as Mars. So this planet is actually the fourth planet from our solar system. Now, I'll give you a brief history about this unique planet. So it's actually named after the Roman god of war. Not only that, it's actually founded by a famous scientist from the Renaissance period known as Galileo Galilei. He founded this planet on the 16th century using a telescope. Now, other than that, it's been existing 4.5 billion years ago. Now, that's way before human existed. So there are some physical characteristics of this planet which I would like to discuss now. Now, first and foremost, the temperature of this planet can range between -140 degrees Celsius to 70 degrees Celsius. Yes, the weathers over there are extreme. Not only that, it has 2 moons. Compared to us, we have only 1 moon, which is known as the moon or Luna. But over here in Mars, it has 2 moons, which name Phobos and Deimos. Both of them are actually asteroids, and Phobos is bigger compared to Deimos. Now, about the surface of the planet, it has rocky mountains and canyons and dark patches of rocks. It also has volcanoes, and some are active and some are not. Other than that, it's also covered, in some places it's covered with ice, which is at the North Pole and the South Pole. Now there are some bite-sized facts about this unique planet. And first of all, why is it red color? When people talk about Mars, they mention it as the red planet. So why is it red color? So it has captivated scientists to know more about the planet. So they have found out that there's high concentration of iron on the surface of the planet. Now, as we all know, when iron is oxidized, the color will be reddish brown. So this is why the Mars surface is reddish brown. Other than that, it's actually the second smallest planet in the solar system, just before Mercury. So there are some mind-blowing facts that you all should know about. And first of all, it has the tallest and the largest mountain in the entire solar system. The name of the mountain is known as Olympus Mons. Now, what's the height? It's 21 kilometers and 600 kilometers in diameter. Compared to the Mount Everest, it's actually tiny, because Mount Everest is just 8 kilometers in height. So this proves that Mars literally has the tallest mountain, and not only tallest, it's the biggest mountain in the solar system. Not only that, it has a vast network of canyons and tunnels. Now, its tunnels can reach up to depth of 7 kilometers with a distance of 7,200 kilometers. Yes, that's a lot of numbers. And other than that, it also has frozen ice on the North Pole and the South Pole. Now, furthermore, you can actually jump 3 times higher on Mars compared to on Earth. Why? Why is that so? So, on Mars, there's 62.5% less gravitational pull compared to on Earth. So you can jump higher on Mars than on Earth. So now, after all these interesting facts, I'm going to talk about common misconceptions of Mars. Now, when people talk about Mars, the first thing that comes to their mind is aliens, grays, and spaceships, influenced by the pop culture, pop music, and movies also. So now, there are no aliens on the planet. There are closest to be aliens are microbials, which are formed by NASA scientists. Yes, they're just tiny aliens, but not aliens as our height. So, not only that, there are no liquid water on the surface of the moon. On the surface of the Mars. Why? This is because there are thin layer of atmosphere on the surface of the Mars. So this causes the gamma radiation, the heat from the sun to evaporate the water. The closest you can find is just frozen lakes of ice at the North and the South Pole. And that's all from me. These are the interesting facts that I'd like to discuss about Mars, and I hope that the doubts are all cleared. And thank you very much.
Hello, I'm Daniel. Okay, so today I'll be talking about the Big Bang Theory. Okay, so first of all, what is Big Bang Theory? Okay, Big Bang Theory is the way how astronomers explain how the universe began. Okay, so it is the idea that the universe began as a single point, then expanded and stretched to grow as large as it is right now. So this idea was by George Lemaitre. Okay, in 1927, an astronomer George Lemaitre said that the universe started as a single point, which means just a dot. Okay, from just a dot, it expanded till it is right now. Okay, so like after 2 years, an astronomer named Edwin Hubble noticed that other galaxies were moving away from us. So there are so many galaxies, and our galaxy, the name of our galaxy is the Milky Way. Okay, And then the furthest galaxies were moving faster than the one close to us. Okay, so this meant that the universe are still expanding, just like what George Lemaitre said. Okay, if things were moving apart, it meant that long ago everything had been closer. As we can see today, there's so many in our universe. There's stars, there's planets, there's comets, there's asteroids. So where did they come from actually? Okay, so this is a bit of history, okay, of the Big Bang Theory. When the universe began, it was just hot, tiny particles mixed with light and energy. As everything expanded, as what we talked here, it becomes from a single point, it expanded, it took up more space and it cooled down. So that means when the universe started, it is in a very high temperature, probably a few million degrees Celsius, and then it becomes to like what it is right now. Okay, so the tiny particles group together from atoms, formed atoms. Atoms grouped together, and after lots of time, atoms came together to form stars and galaxies. The first star created bigger atoms and groups of atoms called molecules, which led to more stars being born. At the same time, galaxies were crashing and grouping together. As new stars were being born and dying, then things like asteroids, comets, planets, and black holes are formed. So this is how the black hole forms too. Okay? And as you all know, our universe is 13.8 billion years old. Okay, it's very long. Okay, and because it got so big and led to such great things, such as asteroids, comets, planets, different planets, some people, and then from that thing, the name came out to Big Bang. Okay, that's all.
Okay, so for today, we're going to be talking about black holes, and we're going to start off with, what is a black hole? See, a black hole is a celestial object or region in space that has a gravitational field strength so intense in magnitude that not even the fastest thing in the universe, light, can escape it. And light travels at 300 million meters per second. And now we are going to be looking at the anatomy of a black hole. So let's work outwards from the center, as you can see in this image that should be right here, if I can somehow put into this video. So in the middle of a black hole lies the singularity, an infinitely dense and infinitely small point in space, and it contains the entire mass of the black hole. The gravitational pull at the singularity is, as you've kind of guessed, infinite, hence the infinite density and all that. Next up comes the event horizon. This is the radius around the singularity when neither mass nor energy can escape. Never ever. Like anything that's stuck in the event horizon will never be able to come out. That's just it. Just say goodbye. The gravitational pull of the singularity is actually too immense for anything to ever come out of the black hole after it passes the event horizon. Next, we're going to be looking at the photon sphere. So the photon sphere, or the light sphere, is basically it's when the gravity is so strong that light, the fastest thing in the universe, is bent, but it's bent in a way that its path is no longer straight, but instead it gets curved and it ends up orbiting the black hole. So it's just a sphere of light going around the black hole, as you can see in this image right here again. And now we will get to the final part, which is the accretion disk. The accretion disk is a disk of superheated gas and dust that travels around the black hole at incredible speeds. Like we're talking about at least 50% the speed of light, which is already incredibly fast. And due to this rapid rotation, electromagnetic radiation is produced in the form of gamma rays, X-rays, etc. that travel throughout the entire universe. And this is actually what helps us detect a black hole in the first place. We detect all the gamma rays, the X-rays, all these different electromagnetic radiation from the black hole. It helps us to find them. Okay, and now we are going to be looking at what a black hole actually looks like. And the previous picture, that's an artist's depiction, as we
Well, we didn't have any pictures of black holes until last year when they took the first one, which should be shown over here. Over here should be around there. And well, what does a black hole look like? See, I mean, you can obviously see it there, but this one's a little tricky because it's called a black hole, but it's not actually black and it's not actually a hole, but we'll get to that later. You see, you can't see a black hole. Before we get into that, let's talk about how seeing something works, okay? So, to put it simply, photons or light particles, light is both a particle and a wave. It's super interesting, wave-particle duality, you gotta love it. But anyways, that's another story. So light particles or light waves bounce off an object and into your eyes, where your brain processes this information and tells you what you're looking at. You know, an orange, an apple, China. But the thing is, with black holes, once light gets too near it, that means once light gets past the event horizon that I mentioned earlier, it'll never come back. It will undergo the ultimate sucking experience and will be pulled into the center of the black hole, the singularity, as we have discussed previously. So basically, what you would see is an empty region of space, a literal hole, but not really a hole. It's black, it's round, and around it will be that photon sphere and the accretion disk and everything else orbiting the black hole at incredible speeds. Alright, now we're going to look at how black holes are made, and this is very interesting, as in theory, anything can become a black hole, even you and I. Me, you and I. You know what I mean. There's something called a Schwarzschild radius. It's really hard to pronounce, Schwarzschild. An incredibly small amount of space that if you were to collapse the entirety of an object into, its density would be so great that its gravitational pull would also be so great that not even light can escape it. And there you have it, you have a black hole. Now, however, there are no known ways to compress regular or irregular objects into their Schwarzschild radii, and so the most common way a black hole is made is when a massive star begins to run out of fuel. This occurs near the end of the star's life, and it's when the inward gravitational pull due to the star, due to its mass, overwhelms the opposing outwards push due to nuclear fusion in the star. And nuclear fusion is basically when two or more atoms are forced to react and fuse, and it produces a lot of energy. Nuclear fusion slows down near the end of the life of the star as the star runs out of reactants. Usually it's hydrogen, helium, you know, hydrogen isotopes. When this happens, the star will collapse into its core and then collapse even further due to its immense gravity, and voila, tada, a singularity is made, and a black hole is born. This type of black hole is called a stellar black hole. Stellar because it's due to the fact of it being a star slash sun slash star, same thing. There are other varieties, but this is the most common one. However, there is another type of black hole, and they're a bit of a mystery to us, and we'll be talking about them next time in a future video. Now, what would happen if you were to fall into a black hole? Well, see, technically, you can never actually fall into a black hole because they aren't actual holes. See, people also tend to assume that black holes are like giant vacuum cleaners, sucking in everything. Just in space, just constantly sucking and pulling everything towards it, gobbling it up and just sucking even further. But no, if that were the case, then any other object, like the sun with a noticeable gravitational pull, should be considered vacuum cleaners as well, as, see, space gets bent due to immense gravity, and that's what causes this sucking effect. But it's not actually sucking, it's just more of space dipping, you know, dipping downwards like this. But anyways, that's a different topic. We'll go back to ours. Back to the topic. As you approach a black hole, an observer a safe distance away from it would see you approaching it as you are approaching it. However, you'd seem to be approaching it at an increasingly slower speed as time goes by, and once you reach the event horizon, you'd appear to freeze in space and eventually fade into red light and then nothingness. This is pretty scary actually, and this is because, again, as we have discussed earlier, nothing can leave the event horizon once it is past, not even light. But the light particles bouncing off of you right outside the event horizon will be able to reach the observer's eyes, But since the gravity is so strong, space itself is warped. And the light waves, light is both particle and wave, remember? The light waves get stretched. Blue light would turn green, then yellow, then orange, then red, and then invisible to the naked eye as it becomes infrared, and then infrared, microwaves, radio waves. That's how it works. And the light's wavelength will get so stretched that eventually the light waves will become barely discernible radio waves. Like, they're so weak they can barely be detected. An easy way to understand this is to draw a wave with a certain wavelength on a rubber sheet and stretch the sheet. The wavelength would increase the same as when light travels in space-time that's being warped by extreme gravitational forces. And this, my friends, is called redshift. Really fun. From your point of view, however, if you were to look back when approaching a black hole, you see the entire universe shrink into a singular point. The closer you get to the singularity, and eventually your atoms near the singularity will be pulled towards it faster than the atoms facing away from it, as in the atoms on your back will be pulled towards the singularity slower than the atoms on your face, meaning your face will get stretched to nothing and it'll get ripped apart completely, and you'll get violently torn apart and atom by atom until there's nothing left. And this process, this brutal process, has a really scary name: spaghettification. Anyways, guys, thank you, and off to the next one over there.
I'm Heike Kais and I'm here to present on the topic about stars. Stars. What are they? They are giant luminous spheres of plasma. There are billions of them in our galaxy. The sun itself is a star. And how are they formed? The stars are formed when gas and dust that is present within the interstellar molecular clouds exceed their critical density and collapse under their own gravity. What are they made of? What are stars made of? The stars are mostly made of hydrogen and helium, which are the lightest elements. But stars are also, most of them are also made of heavier elements such as oxygen, nitrogen, iron, and carbon. And yes, why do we see the stars twinkle? When you look at the night sky and you see the stars and you can see them twinkling. But do they really? No, they don't. They just appear so because of the effects of our atmosphere, because of the temperature difference and the different densities in different areas. There is an effect that is created so as to make them seem like they're twinkling, but they do not really twinkle. So how do the stars help us? The stars from the ancient time itself have been very helpful to us humans. We use stars to navigate to places, and also the motion of the sun against the background stars is what we use to make the calendars. So, why are they important? Why are stars important? Stars are important because that is why we have life on Earth. If there wasn't stars, there wouldn't be life on Earth, because the sun, our sun itself, is a star. And without the sun, there would be no life on Earth. It would not be possible. And the galaxies are stars too. So if there weren't any stars, there would be no galaxies. And also, furthermore, what is a night sky without a without a billion stars twinkling in the sky. Thank you.